Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on waves from October-November 2022, Paper 1, Variant 1. In this lesson, as always, we will discuss these questions in detail so you can improve your conceptual understanding and you can have better understanding of these questions. Let's study together. Let's improve together. For question number 21, it is given to us a signal generator, amplifier, and loudspeaker are used to produce different sound waves in a room. The relationship between the properties of these waves are investigated. Which relationship is not correct? Which one is not correct? And that one will be our answer. If you look at option A, it is given to us amplitude is proportional to wavelength, but there is no any relationship between amplitude and wavelength. So it means this option is incorrect. So this one is incorrect. So this one can be our answer. So this one can be the answer. If you look at option B, it is given to us frequency is inversely proportional to wavelength. So we can find out this one from wave equation, means equation for speed of a wave. V is equal to F times lambda. And from here we can make F the subject. So we can say F over lambda. So from here we can see that for constant speed of a wave, we can see F is inversely proportional to wavelength. So it means this option is correct. So this one is correct. Intensity is proportional to amplitude squared at a given frequency. Yes, this is also true. Intensity is directly proportional to amplitude squared if frequency is constant. Frequency is constant, means the frequency of the wave, if we keep constant and we increase amplitude, it means intensity will increase. And for the option D, it is given to us time period is equal to reciprocal of frequency. This is also true, means time period is equal to 1 over F, means this option is also correct. So our answer for this one is A, because A is incorrect and we need to find out incorrect option. So the answer for this one is A. So this is how you can figure out. And also you need to understand intensity. If frequency is not constant, if frequency change and we keep amplitude constant, how intensity will change? Intensity is directly proportional to frequency square if A is kept constant. So if A is kept constant, so then intensity is directly proportional to frequency square. And this one you need for intensity. This point is a very important one. For question number 22, it is given to us when a guitar string is plucked, it causes longitudinal sound waves in the air, as shown in this figure. The speed of the sound in air is given, that is equal to 340 meters per second, and we need to find out approximate frequency of sound waves. So how we can find out frequency of sound waves? Speed of sound waves is given. So simply we need to understand V is equal to F times lambda. We need to find out frequency. So simply this will be equal to V divided by lambda, means divided by wavelength. And in this case we have value of V, that is equal to 340. So if we can find out value of lambda, then we can figure out value of frequency. So if we look at these waves, means longitudinal sound wave in this air, we can see in this region, if we look at this region, particles are compressed. So in this region, as particles are compressed, we call this region is compression. And in this region, you can see particles are away from each other. So this region is called rarefaction. And again here you can see in this region, particles are compressed. So this region is also compression. So we can say this is also compression. And the wavelength for longitudinal wave, this is the distance between two consecutive compressions or rarefaction. So in this case, we can find the distance between two consecutive compressions, and that distance will be equal to 1 wavelength, lambda. And this distance in this case is equal to 0.5. So lambda is equal to 0.5 meters. So we can write down value of lambda here. So this is 0.5 meters. Now just you need to simplify. So we have 5. This is divided by 10. So we can say this is 340 divided by 5 multiplied by 10. So we can cancel this 10, so we will get 2 here. And so the final answer in this case is 680 hertz. So this is value of frequency, and this is how you can figure out. This question is quite straightforward one. So the answer for this question is B. For question number 23, it is given to us a transverse wave travels along a rope. The diagram shows the rope at time t is equal to 0. The wave is traveling from left to right. The period of the wave is capital T. One particle of the rope is labeled x. Which graph shows the variation with time t of the displacement of particle x between t is equal to 0 and t is equal to 2t. So the particle is at this point, so it's labeled x. Now you need to understand how this particle will move. Wave is moving from left to right, so we can draw this wave for the next instant of time, means after short period of time where the wave will be. So for that purpose, simply you can take the points. This point will go forward, this part of the wave will come here, this part of the wave, this will come a bit forward, this part of the wave, it will come forward. So simply we can draw the wave. So it will come forward, it will come forward here, and this will move forward, and so on. And this one, this will move forward, and this one also, the peak will move forward. Now we can connect these points, so we can see the wave will be at the next instant of time. So this is in a beautiful way you can connect that. So this is how you can connect. Now you can see from here, this particle at point x, this is moving down because it has to follow the wave, so this will go down. Means this particle will go down, and this particle is at equilibrium, so it will go down and it will follow the wave. Or in a very simple way you can understand, particles follow coming wave. In a very simple way, if you even don't draw this one, you can understand the motion of this particle. Particle follows coming wave. Particle follows coming wave. Coming wave. If you look at this particle, if we draw this line here, this part of the wave has already passed, so the particle will follow the coming wave. So if you look at the coming wave, you see particle is here, so it will follow this wave, so it will go down, then it will climb up, then it will go down. So we can also draw like this, then it will go down, then it will go up, then go up, then go down, so like that. So the shape we will see, the particle means will follow. Let me draw with red line. So this is, you will see the displacement of particle with time. How displacement of the particle will vary with time. So from here to here, this is 1 after one period of time, and from here to here, this is after another period of time, meaning 2t. Its motion will be like this, its displacement will change like this. So this is one way, a simpler way to do this one. Otherwise, simply you can draw this wave and you can see. So in this case, if you look at option C and D, so that is not possible because the particle is starting from equilibrium. So we can simply eliminate these two options. So these two are not possible. Now if you look at option A, this is also not possible because the particle from equilibrium, it will go down. So this is going up. So this is not possible. So the best possible answer for this question is B. Means first of all, particle go down. So you can see from here. Try to compare these two. I will be using different color now to give you some feelings about that. So you see in this case this go down. So here you see this goes down. It reaches this point. After this point it go up. You can see this will go up. And after that it go up and then come down to equilibrium. So you can see this part here. And after that it go down to the lowest position. So this go to the lowest. Then it go up to equilibrium. So you can see this goes to equilibrium. And then it reaches crest. This also reaches crest. And after it come back to equilibrium. So it has completed 2 cycles. So this is how you need to understand this type of problem. Very simple way. Just look at this one. Particle follows coming wave. If particle is here, means particle is here, it will follow the coming wave. If particle here, for example, where this particle will go, this will go up. So this will be the part of the wave. Mean this will show the variation of displacement with time and so on. I hope this one is clear to you. So this is how you can answer. So let me explain you this one in a little bit different way so I can clean these things. So let me clean this off. So we can clean this one. So let me draw this wave again. So let me draw this wave to give you some better feelings about that. So I can redraw this wave. So in a simpler way, I can just draw this wave. So this is the wave. Now I can move this wave forward. Now I can simply select this wave. So this wave, simply I can select and I can move this forward. So you can see here, if I move forward, you can see how the particle motion will change. So this is how wave is moving from left to right. So in this case, you will see that this particle will go down, this particle go down, and particle here, this particle will go up, particle here, it will climb up, and the particle which was here before at the top, this particle will go down, and particle here, you will see that one will go up, and so on. So this is how you need to answer this type of problems. I hope this makes sense to you. You can see what is happening. Now let's say if this wave is, for example, is moving to the left, moving to the right, we can also understand that part. Let's say this wave is moving to the right, so we can take this wave. You see, first of all, this wave is here. If this is moving to the right, so this is what will happen. Now this particle will go up, because it will follow this wave. So this is what you need to understand. I hope this makes sense to you. For question number 24, it is given to us a jet aircraft travels at a speed of 0.80 v, and v is the speed of sound. The aircraft directly, very important, directly approaches a stationary observer. The frequency of the sound emitted by the aircraft is 100 Hz. We need to find out which frequency does the observer hear. So this is a typical question about Doppler effect. So in this case, simply we can also sketch. Imagine that this one is the aircraft. So we can say this is aircraft. So this is aircraft. Aircraft is approaching an observer, and the speed of aircraft is 0.80 v, and stationary observer is standing here. So observer is at rest, mean v naught is equal to 0. And we need to find out frequency of the sound heard by observer. This frequency we need to find out, and frequency of the source fs is given, that is equal to 100 Hz. So this frequency is given. So simply it's just simple question about Doppler effect. So we can write down observed frequency. This will be equal to speed of the wave divided by speed of the wave plus minus speed of the source. In this case, observer is at rest, and you need to multiply this one with frequency of source, means the frequency of the sound emitted by source. So now we can simply plug in values. So f naught we need to find out. In this case, source is approaching. So let me write on it, as source is approaching, so f naught has to be greater than fs because source is approaching. So now you can choose, it has to be a negative sign or it has to be a positive sign. F naught has to be greater, so this one has to be negative sign because this denominator has to be smaller than numerator. This has to be smaller, so this one will be higher. So if this denominator, this is lower, this one will be higher. So simply now we can plug in values. We have speed of the wave, mean the speed of sound, that is v, and this is divided by speed of the wave minus speed of the source, that is 0.80 times v, and this one has to be multiplied with frequency of source. So this is frequency of source, means the frequency of sound emitted by source. So this one we can simplify. We can write down this is v divided by v times 1 minus 0.80 multiplied by 100. So this we can be cancelled with this one. So here we will get this is 1 over, we will get this is 0.20 multiplied by 100, and if we solve this one, our final answer will be equal to 500 Hz. So this is the frequency of sound observed by observer. So the answer for this one is D. A very straightforward question. I try to explain you in detail so you can feel how to answer this kind of problems. Otherwise, just simply use formula and you can find the answer. Question 25 says a telescope detects and analyzes some electromagnetic radiation of wavelength 2 centimeters. We need to find out which type of telescope is it. Is it microwave telescope? Is it optical, radio, or X-ray? So we need to understand the type of wave this telescope is detecting. And then based on that, we can also find out type of telescope. So first of all, let's try to understand the wavelength of electromagnetic radiation. In order to remember order of electromagnetic radiation, simply you can remember Granny's X box. Granny's X box, use volts in my room. Use volts in my room. And you can remember the order of electromagnetic radiations. So we will start from here. Room. This is R for radio waves. So these are radio waves. M for microwaves. So we can write down microwaves. I for infrared. So I for infrared. So I for infrared. And V for visible. So this is for visible light. U for UV, ultraviolet. X for X-rays. So X for X-rays, and G for gamma radiations. So this is for gamma. Now let's try to understand how we can remember the wavelength of these radiations. Radio waves. For radio waves, you need to understand the wavelength of radio waves is 1 meter and greater than 1 meter. Means is greater than 1 meter. And for microwaves, the wavelength is from 1 to 10 to minus 3 meters. And for infrared, this is 10 to minus 3 to 10 to minus 6 meters. We are talking about meters. And for visible, the wavelength of visible is from 8 times 10 to minus 7 to 4 times 10 to minus 7. And UV, the wavelength is from 3 times 10 to minus 7 to 10 to minus 8 meters. And X-rays, this is from 10 to minus 8 to 10 to minus 12. And the wavelength of gamma radiations is 10 to minus 12 and smaller than that. And smaller than that. So this is smaller than that. So if you can understand these range of wavelengths, you can answer most of the question. Almost 98% question about electromagnetic spectrum in past papers. Now for this given radiation, wavelength is 2 centimeters. Means this is 10 to minus 2 meters. And this one is in this range. So we have here 10 to minus 2. So it means this is microwave. So the answer for this question has to be A, because this is microwave, and telescope will be microwave telescope. Means the type of radiation is microwave and telescope is microwave telescope, because this telescope is detecting microwaves. So this is microwave telescope. For question number 26, it is given to us two waves of the same type overlap. When does the principle of superposition apply? So first of all, let's try to understand what is principle of superposition. Principle of superposition simply tells us when two waves meet and the resultant displacement of resultant wave is the vector sum of the individual displacements of waves. So simply we can say resultant displacement of resultant wave, or simply you can say resultant displacement is the vector sum of individual displacements, of waves, individual displacements of overlapping waves. And there is no condition for direction of wave, there is no condition for frequency of waves, and there is no condition for amplitude. So it simply means that if you look at option B, when the waves have same amplitude, you need to apply principle of superposition. There is no condition for same amplitude. Even the amplitude is different, still you can apply principle of superposition. Even the frequency is different, still you can apply. Even they are moving in opposite direction or they're moving in the same direction, still you can apply principle of superposition, because principle of superposition is simply how to find the resultant displacement at any given point. So simply you need to add waves. But waves traveling in opposite directions, this is condition for stationary waves, means when stationary waves will be formed. So this is for stationary waves, and this one is also for stationary waves. So these are the conditions for stationary waves. So when stationary wave will be formed, and this is also for stationary wave. So these are conditions for stationary wave, means when stationary wave will be formed, but not condition for principle of superposition. With the help of this principle, simply we can find the resultant displacement at any point. So principle of superposition always applies if waves are of the same type. So the answer for this question is A. For question number 27, it is given to us a stationary sound wave is formed in a tube of length L that is closed at one end. The diagram shows the positions of the nodes and antinodes of the stationary wave. So in this case, we have two nodes. So these are two nodes, and also we have two antinodes. We need to find out which graph shows the variation of the amplitude of the wave with distance x measured from the closed end of the tube, means measured from here. So here distance is equal to 0, and we have node here. So this has to start from 0. So it has to start from 0. Now we need to understand in this case amplitude, for example. Is amplitude is a vector or amplitude is a scalar? Amplitude is scalar quantity because this tells us maximum size of displacement. So you need to understand amplitude is scalar quantity because it tells us maximum size of displacement. So amplitude is scalar because this is the maximum magnitude, maximum size of displacement. So it's a scalar. So now if you look at these given options, we have two nodes, means displacement is equal to 0 two times. So if you look at this one, how many nodes we have? We have 4 nodes in this case. So this option is not possible. If you look at this one, we have in this case also 4 nodes. So this is also not possible. We have only 2 nodes. But if you look at option A, we have 2 nodes. So this can be the answer. This one also have 2 nodes. So this also can be the answer. But now we need to understand amplitude is a scalar. So it cannot be negative. So it is not negative. So the answer for this one is A. So the maximum size of displacement. So it just tells us the size. So size cannot be negative. So the answer for this one is A. Question number 28 says a wave on the surface of water passes through a gap between two barriers and is diffracted as shown in the figure. What happens when the frequency of the wave is halved? Means the frequency become half. So the wavelength will be double. So first of all, let's try to understand when significant diffraction takes place. Significant diffraction takes place. Significant diffraction takes place when the wavelength of the wave is approximately equal to the gap size. Gap size means this gap. This is the gap size. So when the wavelength of the wave, this one is the wavelength of the wave. When the wavelength of the wave is about equal to gap size, there is significant diffraction. And also we need to understand if we, for example, this lambda, if we increase this lambda, but we keep gap size same. So in this case, there will be more diffraction. And on other hand, for example, if we decrease lambda and we keep gap size same, so in this case there will be less diffraction. So these points we need to understand. So in this case there will be less diffraction. So in this case wavelength is increasing because frequency is decreased, so wavelength increased, so there will be more diffraction. So the answer for this question is B, more diffraction. Less diffraction diffraction, this is wrong. No diffraction, this is also wrong. The same amount of diffraction, this is also wrong. So the answer for this question is B. For question number 29, it is given to us interference fringes are produced using light from a double slit. The intensity of the light emerging from each slit is initially the same. The intensity of light emerging from one of the slit is now reduced. How does this affect the interference pattern? So first of all, we will just discuss two cases. We will discuss case 1 first of all. In case 1, it is given to us intensity is the same from two slits. So simply you can imagine these are the waves. They are coming from those two slits. They have the same amplitude. So when these two waves, they will meet and they will interfere constructively, we will get a super crest, means a bright maximum. So we will get this one. So this is when they interfere constructively. And when they will interfere destructively, means their phase difference is 180 degrees in like this. So we will see the dark fringe, means no light. So this is case 1 when the intensity is the same. From two slit, intensity is same. So we can say same intensity, same intensity. So this is same intensity. Now we can discuss the second case when intensity of one slit is reduced. So in this case, we have one wave. This is the initial one. And the second one, its intensity has been decreased, means the amplitude has been decreased. So in this case, we will, when we add these two waves, we will get this bright fringe, but this bright fringe will be dimmer than this one. And so we will say in this case, this one is brighter. So first of all, it is brighter in case 1, and in this case, this is dimmer, means the bright fringes will get dimmer. Now we can go to the second case. For the second case, if we have this is 1, and the second one, this amplitude is smaller than the first one. So in this case, we will get some light. So we will get this one. So in this case, simply you can see. So here we have full darkness, fully dark. So we can say fully dark this one. So this one is fully dark, that this one is brighter. So this is the concept you need to understand in this way, in a beautiful way. I hope this is clear to you. So in this case, simply you will say bright fringes, they get dimmer, and dark fringes, they get brighter. So let's look at given options and try to find out the answer. The bright fringes and dark fringes become brighter. No, this is wrong, because bright fringes, this is the bright fringe. So if you want to write down here, so this is the bright fringe. We have here, this is bright fringe, and this one is dark fringe. So bright fringes get dimmer. So this is wrong. The bright fringes, dark fringes all become darker. This is wrong. The bright fringes become brighter. No, they become darker. Dark fringes become darker. This is wrong. The bright fringes become darker, become dimmer, and dark fringes become brighter. That's true. So the answer for this one is D. For question number 30, it is given to us a diffraction grating has 4.00 times 10 to 5 lines per meter. A beam of light of wavelength 589 times 10 to minus 9 is incident normally on the diffraction grating. What is the angle between the second order maximum and direction of incident beam of light? So this is a typical question about diffraction grating. Let's try to sketch and try to figure out how we can answer this. So first thing is you can simply imagine, in this case, this one is diffraction grating, and we can also draw, in this case, screen. So this one you can imagine that this one is the screen, and the source of light is placed here. So this is placed at the center. So we can say this one is source of light. So simply you can imagine this one is source of light. This is source of light. And from the center at this point, we will observe first bright fringe. So this is central bright fringe, or we can say this is central maxima. Fringe order is equal to 0. And here we will observe another bright fringe, and the order for this one is 1. N is equal to 1, first order. And here we will observe the second order bright fringe, and for this one will be equal to 2. And also in the lower part, we will also observe bright fringes, and for this one will be minus 1. Simply negative means this is in the lower part. So we will also observe another right fringe, and for this one will be -2. Now this question is simply asking us, we need to find out angle between center maximum and the second order maximum. Center maxima and second order maximum means we need to find out value of this angle. This angle we need to find. In order to figure out this angle, simply we need to apply d sine theta. D sine theta is equal to n times lambda, but n in this case is equal to 2, so we will say n has to be equal to 2. And also we need to understand d is equal to 1 over n, so this is value of n is given to us, so simply we can replace d with n. So we can say this is 1 over n, so here we have sine of theta, and this is equal to 2 times lambda. In this case we will get sine of theta. This one will be equal to 2 times capital N times lambda. We need to find angle, so we need to take sine inverse. 2 capital N times lambda. Now we can plug in values. Sine inverse of 2 times n is equal to 4.0 times 10 to 5, and lambda we have, that is 589 times 10 to minus 9. Now simply use your calculator and solve this one. If you solve this, your final answer will be equal to 28.1 degrees. So this is value of this angle, and this is what you need to find out. Pretty straightforward question, just you need to use this formula, and you need to understand what is d, what is n, what is lambda.